Let's apply some implicit differentiation to a related rate with demand and price, which is something we're very used to as consumers. When we see that gas has gone up to $4 a gallon, we are like, okay, we'll ride out on E as long as we can. Versus if you passed a gas sale that was 50 cents a gallon, you would fill up even if your tank was already almost full. So when price goes up, demand goes down. People wait it out. They don't want to buy it right then. But if price goes down, demand goes back up because they see, ooh, this is a great sale. If there were iPhones on sale for $1 and it was the newest iPhone, you would go buy it even if your phone was still working fine. So we have the demand equation for a certain brand of headphones is 100x squared plus 9p squared equals 3,904. So there's our equation. It's actually a little bit nicer than working with shapes because we don't have to figure out, well, how do I relate volume and radius or something like that? We're given our equation that we're going to take the derivative of. So our equation for this one, for the demand, is that 100x squared plus 9p squared equals 3,904. There's their demand equation, where x is in thousands. So if x is 2, they're not just selling 2 headphones that week, they're selling 2,000. So it's in thousands, depending upon the week, and the price is in p dollars. This is also nicer because we don't have to think about, is it inches, centimeters, minutes, seconds, any of that. They give us the units right away. So I'm maybe going to look right here and just start writing them. X and p, and x is in thousands, and p is in dollars. There are my 2 letters that I get from my equation. X and p, they explicitly give us those units. X is in thousands, and p is just in regular dollars. And we're talking about how demand is changing each week. So when we take the derivative of this in a second, we're going to get a dx dt, and that's going to represent thousands of headphones per week. Whereas dp dt, the derivative of price with respect to time, is going to be in dollars per week. So different units also makes it easier to figure out where to put the numbers we're given. If it's in dollars, we're not even going to think about putting it in an x or dx dt spot. It's nice that they're completely different units instead of both dealing with centimeters or inches or something. So we want to figure out how fast is a quantity demanded increasing when x is 4. So they explicitly tell us x is 4, which stands for 4,000 headphones demanded, not just 4. And the unit price per headphone is $16. Well, we filled out x is 4. That was pretty obvious. It says the price per headphone is $16. Is that p or dp dt? Well, to be dp dt, it would have to be in dollars per week, and it would have to say increasing by $16 per week or decreasing by $16 per week. It would have to tell us some more derivative language and also have 2 units. So this must be the regular price. Right now, they're currently selling 4,000 headphones per week when they're priced at $16. But the price, they're going to start dropping it and see if that helps their demand a little bit. The price is dropping at a rate of 10 cents per headphone per week. So we want to start lowering our price and see if that helps our demand a little bit. So we want to do 10 cents, but this is supposed to be in dollars per week, so I'm not going to write it as 10 because 10 would stand for $10. I'm going to write it as 0.1 because that means 10 cents. Or you could do 0.10 if you prefer, so you can see the 10. So there's my 10 cents per week, but be careful, should this be positive or negative? Are we increasing or decreasing our price right now? We are trying to decrease it. We're going to drop our price by just a tiny bit. 10 cents isn't a whole lot, but we want to see, is our demand going to shoot up if we do that, or is it going to stay basically the same? What's going to happen with our demand each week that we drop our price by 10 cents? Is it going to go up, or are people not really going to care? So we're going to take the derivative of our equation here, and we're going to bring down the power, subtract from the new power. So our derivative is going to be 100 times 2 is 200. X And then we just took the derivative of x with respect to time. Bring down the power, subtract from the new power. Same thing for the next one. 9 times 2 is going to give me 18p. And that'll have a dp dt on it. And don't forget about the other side. We're going to take the derivative of that as well. Derivative of 3,904 is just 0, though. So it's nice it goes away. Don't bring that number down. Take the derivative of it. Now I'm going to sub in all of these numbers that I was given and solve for the one variable I don't know. I'm solving for dx dt in this one. So I'm going to do 200 times the x value. Well, x right now is 4, which again stands for 4,000 headphones, not just 4. Then we have dx dt, that's what we're trying to solve for, so I'm going to leave it as a variable, and we will solve for it. Plus 18 times my current price is $16 times dp dt. We're going to start decreasing our price just by $0.1 per week, or 10 cents per week, and see if that helps our demand. So I need to multiply out on both sides. So on the left side there, I have 200 times 4 gives me 800 dx dt. And then I have to do 18 times 16 times negative 0.1. And that gives me negative 28.8. I'm setting that equal to 0. And we're going to solve it like a linear equation, like it's an mx plus b. So we want to get that dx dt on one side by itself. So first thing we can do is add that 28.8 over. And I'll bring that up here. We get 800 dx dt equals 28.8. I still don't quite have dx dt on one side by itself. I need to divide by that 800 that's currently multiplied there. So we'll divide both sides by 800. That way dx dt will be all on its own. And if I do 28.8 divided by 800, I get 0.036. So their demand is changing by 0.036 headphones. That's it? No, we got to look at our units here. This is measured in thousands of headphones per week. Remember, 4 didn't mean 4 headphones, it meant 4,000. So this 0.036 doesn't mean 0.036 of a headphone, it's 0.036 thousand headphones. So I might actually just multiply that by 1,000 and figure out how many headphones is that going to be. It's 36, and I want the correct units on it. I already multiplied it by 1,000, so it's just going to be 36 regular headphones per week. If we wanted to write thousands per week, we would have had to leave it as 0.036 thousand headphones per week, which just kind of melts my brain a little bit. I don't know what 0.036 thousand headphones per week really means. So if we multiply it out, we'll see it's 36 headphones per week. Let me multiply that 1,000. So last little piece, we can write our interpretation. We're going to say first what's happening with the derivative we were given. So as the price drops or decreases, whatever you prefer, as the price drops by 10 cents per week, the demand, what we just found, does what? Is it going to increase or decrease? Well, we got a positive 36, so the demand increases by 36 headphones per week. So dropping by 10 cents does help their demand a little bit. They go up from 4,000 to 4,000 plus 36 each time that they do that each week. So they can decide, is that 10 cents drop worth it, getting just that little bit of extra customers buying their product, which is usually a good idea to start. You kind of sell lower to start out, just get your name out there, and that's probably what this headphone brand is doing.